Good morning to all of my students. This is the subject of machine drawing. This is the fifth semester subject. Subject code PCME 592. Okay, PCME 592, and the lecture is prepared by myself, Mr. Dibyendu Mondal, Assistant Professor of Greater Kolkata College of Engineering and Management, which is situated at Baripur. Okay, first one, we discuss about the syllabus. In our first one, Unit 1, projection and isometric drawing of machines component. Then projection, actually previous semester you have already drawn the different types of projection. And isometric drawing, in case of isometric drawing, at a time three views are visible: front, top and side. Another one is the fasteners, drawing of various views of screw threads, metric and BSW threads, square thread and multi-start threads, nut, bolts, washer, set screw, lock nut and foundation bolt riveted. Then joints, form and properties of riveted head, river heads, different views of different types of riveted lap and bar joint. Drawing of various views of shaft joints, cotter joint and knuckle joint, keys and shaft. Coupling, muff, flanged and flexible. Okay, universal and Oldham's coupling. Actually, one by one you have to draw this one. Today we discuss about nut and bolt. Actually, machine drawing. Machine drawing means drawing related to machine component. How to assemble, how to separate all the different part, and how to assemble different parts are drawn. You have to assemble all the parts. Okay, so our first topic we discuss about nut and bolt. Actually, remember, drawing is a silent language. Okay, drawing, any engineer or any designer can express his visualization or his thinking with the help of drawing language. Actually, all are like all other language, there is some rules and regulations students should follow. Okay, and practice the drawing. So our first topic is the nut and bolt. Okay, first topic, nut and bolt. Hello. Now we discuss about bolted joint. A bolt and nut in combination is a fastening device used to hold two parts together. The body of the bolt, called shank, is cylindrical in form. The head, square or hexagonal in shape, is formed by forging. Screw threads are cut on the other end of the shank. Okay, here clearly drawn. One is the nut, another one is the bolt. This one is the bolt head. Okay, this one is the bolt head, and another one, nuts. Actually, the body of the bolt, called shank, is cylindrical in form. The head, cylindrical in form, the head, square or hexagonal in shape, is formed by forging. Screw threads are cut on the other end of the shank. Nuts in general are square or hexagonal in shape. Actually, nut may be hexagonal or square, and bolt head also be. However, there are other forms of nuts used to suit specific requirement. For nuts, hexagonal shape is preferred to the square one, as it is easy to tighten even in a limited space. This is because with only 1/6 of a turn, the spanner can be reintroduced in the same position. However, square nuts are used when frequent loosening or tightening is required. For example, on job holding devices like vices, tool post in machine, etc. The sharp corners on the head of the bolts and nuts are removed by chamfering. First one, methods of drawing hexagonal bolt head nut. Okay, methods of drawing hexagonal bolt head nut. Actually, student, you have to remember the several empirical formula, okay, regarding D, related to D. Actually, D is given. When you draw something, when you draw the machine drawing, first one, you should remember all the empirical formula. Drawing hexagonal bolt head or nut to the exact dimension is laborious and time consuming. Moreover, as standard bolts and nuts are used, it is necessary to draw them accurately. The following approximate methods are used. First one, empirical relationship. Measure or nominal diameter of bolt, that is the D. Thickness of nut, that is the D. Okay, nominal diameter of bolt D. Thickness of the nut should be D. Width of the nut across the flat surfaces 1.5 D plus 3. W. So D is given. So you have to calculate all the item. Width of nut across flat surfaces W is equal to 1.5 D plus 3 millimeter. Radius of chamfer R is equal to 1.5 D. So this is the complete drawing of hexagonal nut. Okay, hexagonal nut. It looks like a hexagon. Width W is given 1.5 D plus 3. And from corner to corner, that is the 2D. And how you draw? Clearly drawn. First one is a draw the view from above by drawing a circle of diameter W and describe a regular hexagon on it by keeping any two parallel sides of the hexagon horizontal. Project the view from the front and the views from side and mark the height equal to D. With radius R, draw the chamfer arc 2, 1, 3 passing through the point 1 in the front face. Now mark point 4 and 5 lying in the line 2 and 3. This one lying in the line 2 and 3. As your next, you mark 4 and 5. Locate points 8 and 9, the top surface by projecting from the views from above. Draw the chamfer 4, 8, 4 and 8 and 5 and 9. Very interesting. Locate point 6 and 7 lying at the middle of the outer two faces. Draw circular arcs passing through the points 4, 6, 2, 3, 7, 5 after determining the radius R1 geometrically. Project the view from the side and locate the points 10, 11 and 12. Then mark point 13 and 14. Okay. This is the mark 13 and 14. This is the side view. Okay. So this is the top. Okay. Top. This is the first one is the front, top, and another one is the side. Front view, side view, and top view. Top view is the below. And very interesting. There is a 3/4 circle. 3/4 circle indicate one is the D diameter, another one is the 0.85 D chord diameter, and 3/4 circle is the outer one. That indicates the thread should be inner one. Okay, 3/4 circle outer one. So you that indicates according to the drawing language. So the thread is outer one. Now, so this is the complete drawing. One is the D, 2D. Okay. Method of drawing square bolt head nut. Square bolt head and nut may be drawn showing either across flats or corners. First one, in case of square nut, some empirical formulas are different. Actually, measure or nominal diameter of the bolt. In each case, it is given D. Thickness of the nut T, that is equal to D. Width of the nut width of the nut across flat W 1.5D plus 3. Radius of chamfer arc R is equal to 2D. R is equal to 2D. Okay. So here R1 W. So hexagonal and square headed bolt. Figure this one, two views of the hexagonal headed bolt and square headed bolt with the proportions marked. First one, the bolt head 0.75D. Okay, hexagonal headed bolt. This is looks like a hexagon. Length of the bolt L, according to the empirical formula, L is equal to 4D. Okay, and this is the D diameter. So this one, the hexagonal headed bolt 0.75D L, and very interesting, 3/4 is the outer one. 3/4 outer one indicates the thread should be external. Okay, just reverse of this, that is the square headed bolt. Okay, and thickness bolt head 0.75D and length is equal to this and diameter this. So when you draw, first one you draw the hexagon, then you draw the diameter, then first one nominal diameter, another one is the chord diameter. Okay, and if you draw washer, a washer is a cylindrical piece of metal with a hole to receive the bolt. Okay, cylindrical piece. The one is the D plus 1 internal. Okay, some millimeter greater. 2 plus 1, a D plus 1. It is used to give perfect sitting of the nut to distribute the tightening force uniformly to the parts under the joints. Okay, distributed the tightening force uniformly to the parts under the joint. It is also prevents the nut from damaging the metal surface under the joints. Figure 5.16 show an washer with the proportions marked. Okay, so here is the complete drawing. Okay, complete drawing of the nut, bolt and washer. Okay, other forms of bolt, square headed bolt or square neck. This is the another one form, square headed bolt as well as square neck. It is provided with the square neck which fits into a corresponding square hole in the adjacent part, preventing the rotation of the bolt. Okay, preventing the rotation of the bolt. So first one, when you draw 2D chamfer arc 2D 1.5D plus 3 square headed bolt with square neck. Okay, but in our previous drawing the neck is not there. Okay, another one, T shaded bolt with square neck. T shaded bolt, T, it looks like a, this one, it looks like a T. Okay, T shaded bolt, it looks like a T. In this, a square neck provided below the head prevents the rotation of the bolt. Okay, the head prevents the rotation of the bolt. Now, this type of bolt is used for fixing vices, workpieces, etc. to the machine table having T-slots. Hook bolt. This bolt passes through a hole. One part, this is the actually complete drawing, 0.8D. Always remember the thickness of the bolt head, that is the 0.8D. This bolt passes through a hole in one part only, while the other part is gripped by the book, shaped and bolt head. It is used where there is no space for making a bolt hole in one of the parts. Okay, another one is the eye bolt. It looks like an eye bolt. Actually, in order to facilitate lifting heavy machinery like electric generators, motors, turbine, etc. Eye bolts are screwed on their top surfaces. For fitting high eye bolt, a tapped hole is provided above the center of gravity of the machine. Okay. Another one is the start bolt. Start bolt it consists of cylindrical shank with threads both the ends. It is used where there is no place for accommodating the bolt head, or when one of the parts to be joined is too thick to use the ordinary bolt. The stud is first screwed into the two parts to be joined. Usually a thicker one, a stud driver in the form of a thick hexagonal nut with the blind threaded hole is used for the purpose. After placing the second part over a stud, a nut is screwed on over the nut end. It is usual to provide in the second part. This one is the stud. Stud means both side there is a threading. Okay, both side, but there is no head. Both side there is a threading, but there is no head. Nut end and stud end. Plain part. Plain part is the middle part. Middle part there is no thread. Okay. And different types of nuts also be there. Flange nut. This is the hexagonal nut with collar or flange provided integral with it. This permits the use of a bolt. Cap nut, it is hexagonal nut with a cylindrical cap at the top. Okay, dome nut, it is another form of a cap nut. Okay, another one is the capstan nut. This nut is cylindrical in shape with holes drilled laterally in the cup surfaces. A Tommy bar may be used in the holes for turning the nut. Actually, the given clearly different is the first one is the flange nut, cap nut, dome nut. Okay, clearly drawn according to the empirical formula. Okay, capstan nut. Okay, that is the E-ring nut. Actually, this type of nuts are used in expensive machines. Okay, very expensive machine. Another one is the slotted or ring nut. Okay, slotted or ring nut. This nut is in the form of a ring with slots in the cup surface running parallel to the axis. A special C-spanner is used to operate the nut. These nuts are used on large screws where the use of ordinary spanner is convenient. Wing nut. This nut is used when frequent removal is required, such as inspection, covers, lids, etc. It is operated by the thumb. Cap screw and machine screw. Cap screw and machine screw are similar in shape, differing only in their relative sizes. Machine screws are usually smaller in size compared to the cap screw. Okay, so here this is the hexagonal nut, another one is the flat head, another one is the round head. Okay, cheese head, oval head, socket head. Okay, this one. So our today's discussion up to this one. Okay, and next one, actually now we draw in our drawing sheet. First one, hexagonal square headed bolt. Square headed bolt like that. Okay, square headed bolt and nut we have to draw in our own copy. Okay, this is the complete drawing. One is the hexagonal bolt, another one is the square headed bolt. Students should remember all the empirical formula, otherwise drawing is difficult. With the help of calculator you calculate all these things, and then according to the calculation you proceed. Okay, this is the complete drawing. Okay, complete drawing. Okay. This is the class of machine drawing. The subject code is PCME 592. The prerequisite subject of machine drawing That is the fundamental of engineering drawing. You have already drawn in your previous semester. Here machine drawing, here the drawing related to machine. Okay, drawing actually in this subject, machine drawing, you have to draw the elements related to machine component, how to assemble and how to separate the each part of the machine. First one, our first topic is the nut and bolt. Okay, when you draw any nut bolt, first one, you have to know the code. Suppose M16. Actually, drawing is the silent language. You have to express your idea, your visualization with the help of different drawing symbol. Here, M16, only this code is available in your drawing book. M16, what is the significance of M16? Actually, M represent, that is the metric thread. M represent metric thread. And 16, that is the nominal diameter of the bolt. Nominal diameter. Okay. M16, then M means metric thread and 16 means nominal diameter into 1.5. So multiply with 1.5, that is the pitch. 1.5 pitch. Okay, so M16 into 1.5 metric thread, nominal diameter into 1.5. This is given in any drawing. You have to complete the nut and bolt drawing, okay, with the help of different empirical formula related to this. Okay, suppose in case of bolt, there is a bolt head. And this is the shank part. Okay, this is the total distance. This one, that is the width, thickness of the bolt head. That is the, actually 16 is the nominal diameter represented by small d, and all your relationship with the help of empirical formula d. Suppose this is the t, thickness of the bolt head, t is equal to 0.7d. So d is given 16, so you calculate d is equal to 0.7 multiplied by 16, so that is the thickness. Okay, this one, this one, 1.5t plus 3. Okay, and there is a chamfering arc. Suppose this is the midpoint. From here to 1.5t away, there is a center. Put your compass here and draw an arc. Okay, draw an arc. And this is the length of the head, length of the bolt, that is represented by 40. And one third of length, that is the threaded portion. One third of length, that is the threaded portion. Okay, one third of length. Why the total part is not threaded? Due to costing. Okay, so one third of the total length is threaded part. And here 16, so threading. Okay, so threading, actually pitch means distance between two threads. Distance between two consecutive threads, that is the pitch. Okay.
가져오다.
이거 다 대화를 you mark thread length equal to L by 3, 64 divided by 3, approximately 21.2, 21. That is the thread length. Now you have to draw the chamfer circle. Chamfer circle 1.4 d away with the help of compass. You have to draw this. Bolt dimensions are shown here. Okay, so dotted line represent, that is the hidden from the side. The chamfering arc is not visible, so it is represented by the dotted line. Okay, it is represented by the dotted line. After completion the drawing, all of you write down, all dimensions are in millimeter. Okay, in drawing don't represent, suppose the dimension is 30 millimeter, only write down 30 millimeter, centimeter, kilometer or meter. Okay, nothing you have to write down in your drawing sheet. And after completion the drawing, you have to draw the title block. Already learned in your previous semester. First one, you write down name, your department, mechanical engineering, roll number, your class roll number, DT of commencement, date of commencement. Okay, another one is the date of submission, and scale 1:1. 1:1 means your drawing scale, your drawing length of drawing and length of actual drawing, all are same. At last, this is the end of today's class, and this lecture is uploaded in YouTube. If you have any doubt, any query, okay, you may ask. Actually, machine drawing, when you draw, first one you remember the empirical formula. Machine drawing, actually design of machine, in case of design of machine elements, actually machine drawing is the prerequisite of the design of machine elements. So student, when you draw sincerely, you have to draw all the drawing. Okay, and one is the prepared, another one this lecture is uploaded in YouTube. Okay, and this is the lecture number 1. prepared by myself. Okay, thank you.